My name is Ben Lambert. I'm an instructor here at Cloud Academy, and before this, I was a software engineer for many years. I've had the good fortune of being able to work on a lot of really cool web and mobile projects at a lot of different web and mobile development companies. That's given me the freedom to pick the technologies that I've wanted to work on, and so I've got to learn a lot of different technologies, and it's been a lot of fun. Um, because I've worked at mostly smaller companies, I've also had the responsibility of doing a lot of the operations side of things, which has left me with being able to set up a lot of continuous integration and continuous delivery servers, as well as running the production environments at some of these companies. So this has allowed me to learn some of the operations while kind of maintaining my core skill set as a developer. So that's enough about me. We're here to talk about DevOps, which is the fun stuff. So let's get started. We're going to take the first 10 minutes or so, and we're going to talk about DevOps at a pretty high level. And then that'll give us a shared language so that we're kind of speaking about the same thing. And once we're done with that, we're going to talk about who's practicing DevOps. And after that, we'll get into a more detailed discussion about how things are changing for those of us that develop and operate software. So let's get started at a high level. What problem is DevOps trying to solve? So it's common in large companies to structure teams according to their role. So you may have a development team, a QA team, a database team, operations team, security, among others. And it's very common to have each of these teams basically working in isolation. Developers are going to write code and maybe some documentation on installing it, and they're going to send it off to the QA team. And QA does some testing and goes back and forth with the developers to fix some bugs. At some point, the code is going to get sent over the wall, the proverbial wall, and it's going to be handed off to operations to run it in production. Now, ignoring the fact that most companies I've seen allocate a week or so for QA, but no time for developers to fix bugs, this silo pattern is extremely inefficient. Most of the time, the only connection that we as developers have to code running in production is that we have a queue of tickets for production bug fixes. So bug fixes is how we developers know what's going on with our code in production. And so we as developers are disconnected from our code, and QA is spending a lot of time doing testing that really should be automated, and so they're not really utilizing their time well, or management is not utilizing QA's time well. And operations has to support code that is written by developers that may not know what the production environment even looks like. So that's a tough thing for operations folks. Now, if any of this sounds familiar, I'm really sorry because I've been there, I understand. But the good news is that there's a better way, and that better way is DevOps. If you search for a definition of DevOps, you're going to see a lot of opinions. You'll see a lot of different definitions, but what you won't find is any formal, generally agreed upon definition. And the reason it's not strongly defined is that it offers the flexibility for companies to leverage the tenets of DevOps without having to adhere to some strict definition. Whenever you have strict definitions or manifestos, it creates this sort of rigid environment where if you need to deviate from that definition, then you have people getting upset because they follow it to the letter, and that can create some friction among team members. Now, I'm honestly not sure if DevOps was created with this flexibility by design, or if it was just lucky. However, either way, it's better for all of us. So, since there's no agreed upon definition, I'm going to share mine. I call DevOps a philosophy of the efficient development, deployment, and operation of the highest quality software possible. And the reason I call it a philosophy is that it's a system of thinking with a primary concern on developing, deploying, and operating high-quality software. Now, we could debate the definition another time, and that'd probably be a lot of fun, especially if we had a few beers. However, it's a succinct enough definition to be able to remember, and it covers what DevOps is at a high level. So we're going to use it for this discussion, and it'll be kind of our shared starting point. If we consider development, deployment, and operations as a pipeline for your code to flow through, then DevOps is about looking at that pipeline holistically and with goals of making it more efficient and making it produce higher quality products. So the logical question is then, how does DevOps help increase the efficiency of the pipeline and increase your software's quality? It accomplishes both of these through some generally agreed upon tenets. And by generally agreed upon, what I mean is that there's some level of consensus in the technical community that these tenets are a good thing. These tenets are often abbreviated as CAMS, C-A-M-S, which stands for culture, automation, measurement, and sharing. We're going to go through these one at a time, and we'll start with culture. So DevOps as a name is the combination of the abbreviations dev for development and ops for operations. So even the name suggests that DevOps is about bringing teams together. So DevOps culture is about breaking down the silos that prohibit teams from collaborating. As the level of collaboration increases, so does the potential for improved quality and efficiency. But what does that mean, to break down the silos? It means that not only do teams need to collaborate more, but the company values may need to change. And that sort of change tends to happen from the top down. So some of the important values that are out there are things like collaboration, quality, efficiency, security, empathy, transparency, and the list kind of goes on with similar qualities. If your company doesn't value these things, then it's likely no amount of technology is going to help. Take any of those as an example. Let's say quality. If quality isn't a company value, then as an engineer, you likely won't get the time that you need to create unit tests, integration tests, and automated acceptance tests. And the same goes for all of the rest of the values we mentioned. If it isn't a company value, then it's not important to the company, and it tends to be ignored until it's time to place blame for something going wrong. Now, there's an awful lot more we could say about culture. It's one of those topics that really we could talk about all day. However, we don't have a lot of time, so I'm going to keep going, and we're going to talk about automation next. So if you're an engineer, this is where the fun is. Automation removes all of the things that prevent us as engineers from delivering awesome new features. Our goal should be to automate everything that it makes sense to and nothing more. So once you start automating, it can be really easy to just go crazy and try to automate absolutely everything. Trying to automate things that are like user acceptance testing is usually more effort than it's worth. So where we start is by automating continuous integration process. It should build your software and run the unit tests on each commit, and it should notify the team of either success or failure. And a failed build should result in holding off on any new commits that aren't intended to fix the build. So the goal here is to prioritize keeping your software in a working state over doing new work. Now, this is a tough thing to do, so if you're not there yet, really don't feel bad. It's difficult. And then we have the automated continuous delivery process. So this picks up where your CI process left off, and for each successful build from the CI server, it should deploy that code to a staging environment, run the automated acceptance tests, any automated non-functional tests, things like load testing and security audits. And then if all was successful, it should allow us to run any manual tests that we need to run. So it's different than the old school way because we're only having people testing on versions that have passed all of these automated tests, allowing us to kind of catch a lot of the known issues is kind of a crude term, but it allows us to catch a lot of these things that shouldn't make it into production and that are easy to test for. So once the manual testing is complete, the build is considered releasable. And then this is where it's a business decision to do what you want with it at this point. Maybe you deploy it Maybe you hold off and have a scheduled release. It really depends on the business factors. So automation is an important part of getting the code into production quickly and efficiently, but it's also important for managing infrastructure. Being able to manage infrastructure in code is really one of my favorite parts of DevOps, because you can codify how your infrastructure should be laid out, and I think that's incredibly valuable. Next, we're going to talk about measurement. So if you don't know what's really going on with your software and your infrastructure, you can't make informed decisions. So measurement is really important. Remember that we said in the opening that DevOps is about improving the efficiency of the dev, deployment, and operations pipeline. So you need to know what things are going on and how they're performing. So in addition to knowing how your pipeline is performing, you also need to know how your infrastructure is behaving. You need to know, do you need to scale up? Do you need to scale down? All of these things. So monitoring all of this is very important. Next, we're going to talk about sharing, which is the S in the CAMs. This one is a vague one, but not really. What it means is you should be sharing the problems and solutions that you're working on throughout your company, and ideally the community at large, if that's possible in your organization. So when you run into challenges, talk to the different departments, talk to the different people in your company, but also how you solve those problems so that you can kind of all agree on a shared solution, and it kind of prevents some of these other teams from having to re-engineer the wheel. So consider sharing as a facilitator for collaboration and transparency. So we've kind of talked about what DevOps is. We talked about CAMs, these tenets of DevOps, but we haven't talked about why DevOps is important. So the old school ways just didn't scale well. They didn't produce high quality software, or at least, I should rephrase that, they didn't produce the highest quality software possible. And they took too long to really deliver too little. And all of that doesn't support experimentation very well because it takes you so long to do anything. In contrast, DevOps scales better because you should be able to push a button and release to a production environment or any other environment with little to no downtime, just about whenever you want to. And because you're performing automated tests, starting with the most granular unit tests, and all the way up to these acceptance tests, they serve as these gates that will allow you to prevent easily testable issues from making it through all the way to production. So companies practicing DevOps, even if they don't call it that, are deploying dozens and some even hundreds or even thousands of times per day. And because you're able to get code into production so quickly, it allows you to experiment. So that could be A/B testing or just creating a proof of concept to deploy to a staging environment to do some exploratory testing. And that's kind of what we talk about when you hear the term fail fast. If you can get a concept into the hands of the people that want to play with it and use it, they can let you know yes or no, we like this, we don't like that, and you can iterate very quickly. And if it's a failed idea, then you've spent so little time that you have very little invested in that. So failing fast is one of those things that DevOps will allow you to do. At this point, most of the companies out there that are able to deliver software quickly and scale well are practicing some form of DevOps. Now, they may not call it DevOps or anything at all, because some of these companies have grown organically into what we would now label as DevOps, so they don't need to name it. Of the companies that are practicing DevOps, again, even if they don't call it that, some are out there in the community and they share what they've learned. And one of these examples is Etsy. And I really like this as an example because I think most of us as engineers have worked on a platform like the one that Etsy started out with. So in 2008, Etsy was structured in that siloed way that we talked about. Dev teams wrote code, DBAs handled database stuff, and ops teams deployed. They were deploying twice a week, which really it's pretty good even by today's standards. I still talk to some companies that are on a monthly or every 3 month deployments. So twice a week I think is pretty good. But their uptime wasn't great, and they were experiencing a lot of the problems that I think are pretty common. They had all of their business logic and SQL stored procedures on one large database server. And that was becoming a pain point because they were generating so much site traffic. So they recognized that things were kind of rough and that they could do better. And they identified silos as a problem, and the way that they chose to solve it was a designated operations engineer. And what that meant was each development team would have a designated ops person that would be a part of all of their meetings and planning, and could help the developers understand operational concerns as well as serve as an advocate to the rest of the ops team for that project. So this allowed developers some insights into production and operations some insights into development. Some of the things that they started using to help improve efficiency, they used Chef for configuration management. So that allowed them to provision servers and probably some infrastructure. With the push of a button, it'd be all in code. They switched to using MySQL with master replication from Postgres. Now the database isn't really the topic. It doesn't matter that it was Postgres and is now MySQL, but I think at the time maybe MySQL had some better replication. So it's the replication that was really important there. It allowed them to scale their database horizontally, and that's of great value. They started using an ORM to get the business logic out of the database, and they put it all into the code. Has a lot of value to have all of your code already versioned, so everything lives in one place. They started using feature flags to allow features that aren't complete to still be deployed without breaking anything. And they have a self-service feature which allows developers to get a dev VM up and running quickly that kind of mirrors the tech stack that they're using. So all of this resulted in a continuous integration, continuous delivery process that allowed them to deploy to production over 50 times a day, and they've substantially increased their uptime. Think about that for a moment and how cool that is. They're able to push one button and deploy to production, and they have better uptime. And by better, I mean great. 5 out of the last 6 months had 100% uptime, and 1 month, I think it was like April, had 99.95% uptime. That's according to pingdom.com, and that's really cool. 5 months, 100% uptime, that is awesome. So with the right people, processes, and tools, creating something like this is possible. Now, Etsy isn't alone in this. Disney, Netflix, Amazon, Adobe, Facebook, IBM, among so many others, are all using these same DevOps practices to efficiently deliver high-quality software, and their stories are all pretty similar. Okay, so we've talked about what DevOps is. We've talked about some of the companies that are using it, but what does it mean for us as engineers? How are things changing? So for us as developers, sysadmins, and all the rest of the engineers, the cloud just went and changed everything on us. Back in the day, we were able to develop in our local development environment that kind of looked nothing like production, and most of them were kind of cobbled together. And production was quite possibly a system that didn't need to scale horizontally because the demands for traffic for most of us just weren't that high. But nowadays, every software engineer, whether it's a developer, operations, QA, security, we all have so much more that we need to know in order to stay relevant. I had a coworker some time ago who was a junior developer, or at least at the time, and he was asked to set up a production environment for a project he'd been working on. It was a .NET application hosted on AWS behind an elastic load balancer. And so he set up the environment on an EC2 instance, and everything looked good. He cloned that server and added that to the load balancer and started seeing some odd behavior. And for those of you listening, you've possibly already diagnosed it. And with a little bit more information, I think you'll definitely have. Uh, Sometimes he'd log in and he would start working, and then he would click on something and he'd be logged out. So it would seem kind of sporadic. Sometimes he was logged in, sometimes he wasn't. And he spent hours trying to figure out why the things just weren't working. Locally, everything looked fine. And I don't know, maybe he was too embarrassed to ask another developer. Maybe he was just really focused and lost track of time. The problem, if you've guessed it already, congrats. The issue was that each server had its own session state, and the load balancer wasn't using sticky sessions. So he'd bounce between the two of them, and what he was seeing seemed like, sporadic behavior. Now, he'd never had to think about session state before and how it works in a load balanced environment. That's just, he'd always kind of done local development and then handed it off to have somebody else run it. So he learned really quickly when it was up to him to get it in production. So the reason I mention this is I think this example kind of helps show that there's a lot of value in learning more than what's considered your area of the software lifecycle. So how do we as engineers future-proof our knowledge, at least as best as that is possible? Here's what I recommend, and these are the things that I think apply to developers, ops, QA, and security, and even management. Really, I think these skills are just invaluable for anyone in the tech field. Now, some of you listening are already going to know some of this because your role in the engineering world already requires it. But I want to go through them all anyway, just so we have a complete list. So first up is learn to code. I think this is crucial for all disciplines of software engineers. I like to recommend Python. I think it's clean, it's concise, and it's multi-purpose. Python is widely used and can build out a complex application as well as process large data sets, or you can just script out common operations or security tasks. So if you have another language you're drawn to, that's fine. The thing is to pick a language and learn the fundamentals. Once you know the fundamentals, going to another language will be easier. And every time you go to a new language, it'll be easier and easier because you have all those features from the previous ones to kind of inform and shape your understanding of the new one. Knowing how to code will allow you a new tool set for solving problems, as well as being able to take existing open source tools and modifying them to work for you. Here in this example, we have some Python that I found online. It's a snippet of printing off a list of S3 buckets from AWS. So even if you're not sure how to code, take a look at this and you'll see that it kind of reads a little bit like English. It's not too bad. So with a few lines of code, you're able to do a lot, and it's pretty powerful. Everything is being turned into code nowadays, so learning to code is invaluable. If you want to learn to code, I like to use Treehouse as a recommendation. They have a great platform. They have great instructors. So check out their Python courses. Next up is learn a configuration management tool. There are some great ones out there. I gravitate towards Ansible. However, pick any of the well-known options and dive in. Chef, Puppet, SaltStack, Ansible. I think as long as it has a reasonable base of users, you can't go wrong. So these tools are useful to developers because it allows us to provision our development environments using Vagrant and VirtualBox. And they're useful for ops because they get to provision servers and even entire environments. Now, for security, I like to use configuration management tools to script out phases of a penetration test. I use it to run scans against different machines, and having it all in an Ansible playbook allows me to have it under source control. Now, you can do the exact same thing in shell scripts. That's fine. The reason I like using a configuration management tool is it allows me to orchestrate things from my computer so I can have other servers running different scans against different systems. It just lets me boss around a bunch of computers in a centralized method. So that's why I like it. And for QA, it's similar. Configuration management tools are useful for orchestrating different tests from different servers. So there's a lot of value there. Let's take a look at an example of an Ansible playbook. This is an example of using Ansible to deploy a to-do application from an apt-get repo. And this playbook allows us to deploy to any AWS EC2 server that has a tag named environment and the value equal to whatever it is we pass in on the command line. Now, I think these tools are becoming a staple, so knowing at least one of them is going to be really useful. If you want to learn one of these tools, I recommend go to the official site for whichever one you want to dive into and start with their documentation. Most of them are really good, and once you have a baseline for the actual tool itself, you'll have some place to start with actually diving into it in depth. And then you'll be able to dive into the community and ask questions on the subreddits for any of these tools. Next, learn a continuous integration, continuous delivery tool. The concepts for these tools are the same roughly across these different tools. They're basically different forms of automation servers. Learning any of them is going to allow you to better acclimate when your company inevitably starts using one if they're not already. As a side note for security engineers watching, these tend to be configured by people that don't have a strong focus on security, and they also tend to offer up the keys to the kingdom, so to speak. So when your company implements them, you'll want to perform a full audit. If you want to learn more about these tools, just like the configuration management, go to their official website for the one that you're interested in and start with their documentation and then kind of move on from there. Next is learn a containerization technology. Now, you don't need to use it every day. You don't need to be an expert, but containers are getting better and better all the time. And if they continue to evolve, they will most likely be the method of choice for immutable deployments for most of the companies out there. For developers, being able to build your code in a container allows you to say it works on my machine and have that actually mean something. And for ops, you'll be able to deploy immutable containers, allowing for potentially faster deployments. There's a little bit more time up front to build these containers, but the actual deployment process tends to be a lot faster. And the ability to roll back to a previous container is very valuable. And it allows a level of portability across different Linux distributions. So that's also very valuable. Now, containers right now come with some security concerns. It's not all fun and games, but learning about this potential security issues now and keeping up on how the containers evolve and how they solve these problems will have you ready when they become more and more mainstream to be ready to secure these. Next, learn a cloud platform from the perspective of a solutions architect. Okay, so even if you don't care to take the final step and get certified, I think this information is just invaluable. Some of my colleagues, next time we meet up, might punch me in the nose for saying this, but like I said, even if you don't get certified, the knowledge is very important. Knowing how to architect a cloud system as a developer will help you to know what tools are out there that will help you build better systems. And if you're working on an existing thing, you'll be able to identify when a project isn't following the current best practices for architecture. For operations, this allows you to better understand where the interactions happen and where likely failures will occur. And I think that's just exceptionally valuable, knowing what might fail because you know where the interactions are. For QA, it's very similar to the ops. Knowing where things might break allow you to help the developers pinpoint where things are going wrong. And for security, this will help you better understand the attack surface and identify likely attack vectors. If you want to learn more about this, check out the cloud vendors' documents. Most of them have really good documentation. And if you're not into reading a bunch of documentation, we have a lot of really good courses that distill that documentation into just the important parts. The upside of the course, if you've gone through the courses, then when you're ready to get certified, if you want to take that final step, then you'll be able to do that. Next, deploy something and keep it running. Ideally, this would be something that you've written, but it doesn't have to be. Deploying something to a production-like environment is exceptionally valuable. When you deploy it to a production environment, did you cause any downtime? If so, why? And if not, why? Because it's not enough to understand why things broke. You really need to understand why things worked, so that if things are working well, maybe 90% of the time, and there's some edge case that causes them to not work, you need to understand where those are. So knowing why things work is as valuable as why things broke. To learn this, you could use our labs, which are really good. They allow you to deploy things to production environments. It gives you a chance to kind of play around with AWS, see the console, see how things work. And I think that's just invaluable. Once you've played around with some of the labs, you could also set up your own AWS environment, and that will allow you to play around with AWS. Doesn't have to be AWS, it could be any cloud provider, but using the smallest compute instances that they have will either be free or very inexpensive, and so the educational value tends to be worth that little expense that you'll see. Make sure you shut down the instances when you're done, otherwise you're going to keep getting charged for them. So next, we have TroubleshootOutage. The ability to diagnose a problem is, in my opinion, one of the best skills that an engineer can have. And by practicing fixing broken systems, you're going to gain a deeper understanding of not just that system, but how other systems are likely built. Next up is break something. Ideally, something of yours. As long as it's not something of mine, we're probably good. But the best way to build resilient systems is by practicing system failures. Netflix does this with tools like Chaos Monkey, and you should too. Now, you don't have to use Chaos Monkey. You can break things on your own or with other tools. Turn off components. See what it breaks. See how resilient your system is. It will help you to make sure that your systems are redundant and self-healing. And last on the list is read up on the tech blogs at least once a week. Now, this can be daunting. Most of us have full-time jobs, and finding the time to read a bunch of articles is challenging. So much can change in the tech world in such a short time frame that this will help you to keep up. So I think there are a lot of just wonderful places to find this information. I'm going to list off a few that I like, and you guys should reach out to me on the community forums and share what tech blogs you're into, because I would love to hear from you. So first up, I think the Netflix tech blog is really good. Techblog.netflix.com is a great resource. Etsy has some great stuff at codeascraft.com. And while I am, of course, biased, I think we at Cloud Academy have some awesome stuff, because we have a lot of different topics regarding stuff like machine learning, or regarding cloud platforms like AWS or Google Cloud Platform, Azure, and DevOps. So it's a wide variety of topics. And Amazon, they have just wonderful stuff. aws.amazon.com/blogs. Check those out. I think they're valuable, and I want to hear from you guys on the community forums what you guys are into. So I just went through a list of 9 items, and I said that I think knowing those things kind of help future-proof your knowledge. But why? I think the roles of developers are changing. I think it's becoming a little bit more obvious as we're going through and seeing things like different serverless technologies. And I think these roles are changing all the more in smaller companies. With cloud platforms offering things like Google's App Engine, and Amazon's Elastic Beanstalk, amongst others. We as developers are getting tasked with managing and running the code that we write in production. So that doesn't mean that ops is going to go away, but we as developers, and nor should it, I think ops is an invaluable role, but we as developers need to understand how to keep our code running at scale. So the role for ops is changing too. More and more, I'm seeing that operations is kind of being turned into site reliability engineers, which is a really cool role, and I think is a lot of fun. What it means to be a site reliability engineer is that you're not only responsible for keeping large, complex systems up and running, you're also spending some time writing code. And it might be like 50-50. It depends on the organization. But site reliability engineers have to build the rocket ship as it's flying. That's a phrase that I heard in a talk, and I thought that was kind of cool. The role of security is changing too. As companies start implementing continuous delivery pipeline, they're just getting their code out there faster and faster. They're deploying code dozens of times per day, and security engineers are expected to keep up. That is not easy. You don't have the time as a security engineer in that continuous delivery process to thoroughly manually test every single build that makes it into production. So you as a security engineer are going to have to help create these different security tests that are automated as part of the continuous integration through continuous delivery pipeline, allowing you to just do kind of a more in-depth manual penetration test or security audit on some set schedule. And the same applies to QA. QA has to help shape the tests that are going to be automated as part of this continuous delivery process. And that will allow them to free up their time to really focus their manual effort on the things that are more important to do manually than automated. So, having this broader knowledge will allow you to more seamlessly shift between roles as roles start to morph and change. Now we're coming into a phase where developers need to know how to operate their code in production, and operations needs to know how to code so they can help to better understand the systems that they're operating, and they'll be able to create automation tools so they can better support that stuff. They'll also, operations is kind of having to write a lot of code in a lot of companies now as they shift into site reliability engineers. So knowing the code is going to be invaluable. The companies that are out there that are practicing DevOps, they're shifting teams around, they're cross-training them, and they really are just expecting more out of each member of the team. And the results are speaking for themselves. Companies like Disney are getting great value out of this shift. I want to share a slide that was taken from a talk presented at a DevOps conference by Jason Cox, who is the Director of Systems Engineering at Disney. In his presentation, he talked about how the ops team transitioned into system engineers because that was what was required of them to operate at scale for Disney. Check out some of these numbers. I'm going to highlight the ones that I think stand out as being particularly awesome, but feel free to pause and take a look. So ABC is now able to scale from 300 to 700 servers in 15 to 30 minutes. And that's just awesome. In the time that it would take me to run out and get some fast food and come back, they've already basically doubled their server capacity. That is just very cool to me. Their Parks and Resorts Online was able to test their disaster recovery plan and deploy their entire tech stack in 5 minutes to over 200 servers in their disaster recovery data center. This is amazing. Nobody wants to do disaster recovery planning, let alone disaster recovery testing. So that they were actually able to do this is awesome, that they were actually able to get it to the point where with the push of a button in 5 minutes time they could have it all done is amazing. So kudos to them. So I mean, you can see that there's a lot of real world value in practicing DevOps. Disney gained levels of efficiency that I just don't think would happen from manual efforts because they had everything in code. So it's all becoming code. Most everything in a modern tech stack is done in code. Obviously, the software that we write, it's code. The automated tests that we write is in code. But the ability to provision a server is also being done in code. You can use tools like Ansible, Chef, Puppet, and others that are in that kind of similar space to specify how a server should be set up and provisioned, what kind of settings it should have, what patch levels, what software it should have installed, etc. And then the tool goes and does this for you. And that's just an amazing part of the DevOps kind of automation stuff. Now, infrastructure is being done in code too. You've probably heard the term infrastructure as code. And what it means is you can create an entire infrastructure and provision all the servers and get that environment live with the push of a single button if it's all in code. Having everything in code allows us as engineers to have it under version control, which means we can collaborate on things like infrastructure. I could install the area, maybe the Django application in an environment, and then I could send off the scripts and have one of my colleagues install the Nginx portion if that's in their wheelhouse. So you could collaborate on these different pieces and then run it and see how it all performs, and it's an exceptionally valuable thing. So learning to code is important, and learning about the tools mentioned earlier is also important. Everything is becoming code. Knowing to code is going to be the new literacy, so it's invaluable. Now, we've kind of talked about DevOps at a pretty high level on how to get started and the things that I think are invaluable to learn. Where do you go to learn more? We have some courses on Introduction to DevOps, which I'm partial to. I created it. So I think the Introduction to DevOps is going to talk about some of the stuff we talked about today, and then it's going to go a little bit further. And then once you've completed that, move on to the Introduction to Continuous Integration. It's going to teach you all the fundamentals about continuous integration. And then you can move on to the Introduction to Continuous Delivery. And I think that one, once you're at that point, is incredibly valuable because continuous delivery is a technique that every company is moving towards. Even if they're not there yet, that's the goal of a lot of software companies. So it's incredibly valuable. And I'm working on another course as we speak, and it will be unveiled shortly, which is going to be an introduction to operational concerns. So I'll be talking more about that in the coming weeks. So before we wrap up, I want to make a couple recommendations for required reading. Just 2 books that are the ones for now, and then we can talk about it on the community forums, what books you guys are reading, why you think they're valuable, and we can maybe get started a recommended reading for the community. First up is The Phoenix Project by Gene Kim and George Spafford and Kevin Bear. This is a very entertaining read. I think this is just wonderful. It's going to help you better understand DevOps, but it's not some dry technical thing. It's a kind of a story about this company. I don't want to spoil anything. Go out and buy this book. It's wonderful. I can't say enough about it. And I have as much praise for the next book: Continuous Delivery, Reliable Software Releases Through Build, Test, and Deployment Automation. David Farley and Jez Humble. The title says it all. It's about continuous delivery. It has some wonderful insights into the topic of continuous delivery, and it will get you started thinking about what a continuous delivery process should and should not look like. So at this point, I think that we've kind of covered as much as we have time for. I want to read off a couple of questions from the community here and get those pulled up on my screen. Give me 1 second. Okay, so here's a really good question. How is security integrated into DevOps? So right now, security isn't really integrated in every company. Like I said, every company gets to do things differently, and that's kind of the beauty of DevOps. It's more of a philosophy. And so some companies are integrating it by using automated processes in the different phases of the pipeline. So they might do static code analysis at the continuous integration process, and they might do something a little more dynamic at the continuous delivery process, testing for the OWASP top 10, SQL injection, cross-site scripting, misconfigurations, all of these things. So you should try and automate as much as you can in these different phases that are part of the automated testing. Next, let's see. Does there exist a set of tools specifically for AWS that help to deliver code? The answer is yes. If you're in the AWS console and you look under the development tools, you'll see they have things like code deploy, and even things like Elastic Beanstalk will help you with deploying your code in a way that has minimal or no downtime. So things like Elastic Beanstalk will use a blue-green deployment model that will help out. Where can I get real world experience with DevOps? Like I said, DevOps is a philosophy. It's a way of looking at the software development lifecycle holistically and with a view of efficiency and quality. So because it's a kind of a lens to see that through, you'd get the experience in either development, sysadmin, QA, security. You could take any of those approaches, but when you're there, you really want to be considering the entire process. If you can get into working at a company that doesn't have these silos, that's going to be your best option, I think. If you are in a company that's kind of siloed, where each department is kind of doing their own thing, dev writes code, they hand it over to operations to run, then pick some tools, configuration management tools. Learn these on your own time as best you can. I know it's tough to find the time, but try and learn these principles. Learn the cloud platforms from the perspective of a solutions engineer. Learn to code. This will help you to kind of transition into the knowledge you need that will allow you to work at a company that really practices DevOps the right way, if there is such a thing. So hopefully that kind of answers that question. Which cloud platform do I think is most compatible with DevOps? I don't think there's any right answer here. I think you could use DevOps practices in all of them really well. If there's one that doesn't play well, I'm not familiar with it. So I'll leave that to you guys to hit me up on the user forums and on the community forums. Let me know if there's a cloud platform that just doesn't play well with DevOps. Can I suggest which configuration management tool is better? Oh, better is a very subjective thing, especially when we're talking about something like this. There are a lot of really good options, and even if no matter what platform, if you're on Windows, you can look at Microsoft has their desired state configuration tool. It's a part of the PowerShell family. So no matter whether you're on Windows or Linux, you have options. Ansible, Chef, Puppet, SaltStack. These are the kind of ones that a lot of people know, and there's a reason for that, because they're really good tools. I like Ansible. because I like the YAML playbooks. I think that they offer a lot of power and ease of kind of typing out. But behind the scenes, you could create a module with just about any language you want that will interact through this same YAML interface, or abstraction, I guess is a better term. So I like Ansible. It's going to run on every Linux environment that has Python. It doesn't require an agent to be installed on the client, so you can use it on just about every Linux platform. Chef is a great option if you already know Ruby, or if you know a language that's kind of similar like Python. Then that's a great option. If you feel comfortable programming with their DSL, it's a wonderful tool. I can't speak highly enough about it. So let's see. It looks like that's about all we have time for. If you guys have further questions, I want you to hit me up on the Cloud Academy community forums. You can also reach me on Twitter at @sowhelmed, and I'll respond to anything you have there. And so, yeah, I look forward to the next webinar, and I look forward to interacting with you guys on the forums. All right, thanks everyone. Have a good day.